Hello everybody, welcome to a new week, welcome to a new Monday. I thought, as last week was quite a heavy maths week, there is more to do with percentages, quite a lot more to do with percentages, but I thought we'd leave it for a bit because I know it was a bit of a heavy week. So I thought we'd do something a bit lighter and fluffier and we'd have a go at some shape this week because we haven't really done much shape this year. So, first of all, does anybody know this word, polygon? You will have heard it before. You would certainly have heard it in year 4, probably year 3. But it's whether you can remember what it is. So just take a second. Can you remember what a polygon is? If you can't, don't worry, because I'm about to tell you. So here are all the things that define a polygon. So it is a 2D shape. I've made the mistake of not turning my pen on again. It is a 2D shape. It is a closed shape, and by that I mean that the sides all meet. So that is not a closed shape, that's an open shape. But by a closed shape I mean that all the sides meet. Okay. It is also either regular or irregular. It can be either one of those. And if you're not sure what I mean by that, don't worry, we're going to come on to that later. It always has 3 or more angles and corners and 3 or more sides. And that's because if it only had 2, you wouldn't be able to close it. So it's got to have 3 or more. And something very important about it is that all the sides are straight, all of them. Okay, 2D, closed, could be regular or irregular, 3 or more sides, angles and corners, and all its sides are straight. So if you have a look at these 3 shapes here, can you tell me which are polygons and which are not polygons? Think back to these definitions and have a look at these shapes. Which are polygons and which are not? I'll just give you a second to have a look at those. Shape number 1. This one has 3 or more straight sides. It's closed, all the sides meet. It's got 3 corners, 3 angles, all the sides are straight. It's 2D, it is a polygon. This shape in the middle has 3 sides, 3 or more sides. I can only see 1 corner. This is not a corner because a corner, or a vertice, is where 2 straight lines meet. And here, they're not straight lines. So it's only got 1 corner and 1 angle. It is 2D and it's closed, but do you remember all the sides had to be straight? This is not a straight side. So this one is not a polygon. And this final one, 3 or more sides. It's closed, it's 2D, 3 or more angles or corners, all the sides are straight. It is a polygon. Something that's quite interesting, a shape that you will know right back from your reception days is, of course, a circle. Sorry about my badly drawn circle there, and that's not even a closed circle, is it? A circle. Is a circle a polygon? No, it's not, because none of the sides are straight. It's got 1 side and it's not straight. So although it's a really common shape, it's not a polygon. Okay, now we've looked at polygons, we're going to look at those 2 words, regular and irregular. Do you know what those mean in terms of shapes? We're talking about 2D shapes here. Let's have a look. Have a look at these shapes. Can you tell me which are regular and which are irregular? Let's have a look. We need to work out what a regular shape is. Okay, I will tell you that this one is regular, this one is regular, this one, again, although it's a really common shape, it's a rectangle, it is not regular. and this one is also not regular. So what do these two shapes have in common? Let's have a look. They've got different numbers of sides and corners, but when I look closely at those sides and corners, I can see that all the sides are the same length on both of these shapes. As well as that, all the angles are equal. The angles, remember, are the distance. When two lines meet, it's the distance between them. In other words, it's the inside of the corner, but it's really where the distance between two lines measured in degrees, and we'll do that another day. But all the angles here are equal. In this case, they're right angles, and all the angles here are equal. In this case, they're obtuse angles. On the rectangle, although we've got 4 right angles, like the square, if you look at the sides, the opposite sides are equal, but not all 4 are equal. So that rectangle is not a regular shape. And this shape here looks a bit like a house. This is actually called an irregular pentagon, this shape, because it is a pentagon in that it's got 5 sides, but it's not a regular pentagon like this one. So this has got 4 angles. These two are the same, these two are the same, and this one is on its own. So not all the angles are equal, and we have 3 sides the same length here, but 2 different ones here. So here we have 2 pentagons, one regular, this one here, one irregular, and over here, can anyone remember the name that will cover both of these shapes? A 4-sided shape. It is a quadrilateral. So here, so here we have a regular quadrilateral and an irregular quadrilateral. So for a shape to be regular, all the sides are the same length and all the angles are the same size. Both of those things. It has to be both. There is an example of a shape, which I'll try and draw. Sorry about my wobbly lines. I don't have straight lines on this. That wasn't quite right. Let me have another go. This shape here is called a rhombus. And on a rhombus, all 4 sides are the same length, but the angles are different. The opposite angles are equal, but they're not the same as the ones next to them. So although the sides are the same length, it's irregular. So it's very important that you say both the sides are the same length and the angles are the same size on a regular shape. Okay, so irregular shapes then are the opposite. Not all the sides the same length, not all the angles the same size. Even if it's just one that's different, it's still irregular. So here are some examples of some regular polygons. How many of these do you know the name of? I'll just give you a second to have a look through. What I suggest you do is count some sides and see how many sides they've got. See how many you know. So have a second, see if you can name any of those shapes. Okay, if you are still going, just pause the video now and I'll carry on, but you can pause the video and keep naming. Okay, so this page shows you the names of those shapes. So what I did, as you can see here, is I went round and counted the number of sides. So I knew this one had 10, a 10-sided shape. They're in a bit of a funny order, this poster. There doesn't seem to be any logic to the order they're in. Sorry about that. But this one here is a 10-sided shape, and that's called a decagon. The next one I hope you knew, 8-sided shape, like an octopus, would be an octagon. This one, a 12-sided shape, is called a dodecagon. Dodecagon. Now this one, 4 sides. Obviously, you would have known a square. Did any of you say it's also a regular quadrilateral? All of these are regular, actually. I should have added, actually, regular to the start of all of these, because they are regular. The only ones that don't need it is if you just use the name square and if you just use the name equilateral triangle. They don't need the word regular, but regular quadrilateral does. Okay, heptagon is a 7-sided shape. Nonagon is a 9-sided shape. Pentagon, I hope you knew, that was a 5-sided shape. An equilateral triangle is a 3-sided shape where all the sides are the same length. And a hexagon is our 6-sided shape. It's really important that you try and know as many of those as possible. But it's also important that you realise you can have all of these shapes except square and equilateral triangle as irregular as well. You can have irregular triangles and irregular quadrilaterals, but square by its very nature is regular, and equilateral triangle by its very nature is regular. Okay, so here are some of them. I quite like the colours on this picture, which is why I chose it. And there's a bit more information about them here. So I want you to just pause the video now and have a read of the information, because it also tells you what the angles are of all of these. Remember, the angles will be equal in all of these, and it tells you what the angles are. Of course, it can't tell you the length because the shape can be as big as you want it to be, but the angles will always be the same. So pause the video now and have a look at these. Okay. This sheet shows you some irregular shapes. Rectangle, a lot of people get confused because it's such a standard basic shape, a really familiar shape that you learn right back in reception or even nursery. People always think it is regular because it's a normal sort of shape to us, but it's not. It is actually irregular because of the length of the sides. So we could also call it an irregular quadrilateral. Here we've got a right-angled triangle. This is actually a scalene triangle by the look of it because all 3 sides are different. You can also have an isosceles triangle, which is where two... I'm really sorry, I can't draw straight lines with this pen. I wish this app had straight lines on it. 2 sides. That's almost a quadrilateral, equilateral. I don't think I'm going to bother. I can't quite do it. There we go. There we go. An isosceles triangle. One day we'll look at triangles in more detail and I'll actually find you some proper pictures of triangles so it's not me trying to draw them badly. Okay, so this is a right-angled and that's a scalene triangle because all 3 are different lengths, and we have got an isosceles, which is 2 the same but 1 different. We'll look at those in more depth another time. Here we have an irregular quadrilateral. This particular quadrilateral looks a little bit like a trapezium, but I don't think it's quite a trapezium actually, because that looks longer than that. Yeah, it's not quite. I think that would have to come out at slightly more of an angle. So there's an irregular quadrilateral, another irregular quadrilateral. We've got an irregular pentagon, irregular hexagon. Can you see how these sides don't always have to sort of come outwards? This one, they're going inwards, which is interesting. And this angle here, this internal angle here, we're going to look at in more depth tomorrow, but that's actually a reflex angle, which is unusual inside a shape. We'll see more about that tomorrow. And again, actually here, there's a reflex angle, just there. So this is an irregular hexagon, because it's got 6 sides, and this arrow shape has got 8 sides, so it's an irregular octagon. So just again, pause the video and have a read through of the bits of information there. Okay, on this page are lots and lots and lots of shapes. Some of them are regular, some of them are irregular. I would like you to pause the video again, and I want you to guess which one, well not guess, work out which ones you think are regular and which ones you think are irregular. Okay, maybe you could draw a grid on a piece of paper with 4 rows going across and 4 rows going down so that they correspond to a shape, and you could just write I for irregular or R for regular in each box. So pause the video and have a go at doing that. Okay, let's go through them and see if you got them right. This first blue shape here, I can see it's a quadrilateral. I can see we've got 2 right angles at the top, but these 2 are definitely not, sorry, at the bottom, but these 2 are definitely not right angles. And also, the sides are all different lengths. So that one is definitely irregular. Let's go across to this next one. 1, 2, 3, 4, 5. It's a pentagon. It looks to me like all those sides are the same length and all the angles are the same. So I'm going to say that is a regular pentagon. This next shape, it's got some lovely symmetry in it, if you look. But opposite angles are equal, but they're not equal all 4 of them, and I've got lots of different lengths of sides. This is an irregular quadrilateral, and it's actually called a trapezium. This shape, it's actually an isosceles trapezium. So it's an irregular shape and it's an isosceles trapezium. The reason I know it's an isosceles one is because if I put a top on it, it would be an isosceles triangle. So I know it's a trapezium, and I now know it's an isosceles trapezium because I know I could turn it into an isosceles triangle, but it's also an irregular quadrilateral. Okay, this one looks fairly familiar. 4 right angles, 4 straight sides, all the same length. That's a square. It's regular. Down here, 4 right angles, check. It's a quadrilateral, but not all the same length. It's a rectangle. Opposite sides are equal, but they're not all 4 equal. So it's a rectangle or an irregular quadrilateral. Here is a scalene triangle, but this one's not a right angle scalene triangle. It's just a scalene triangle without a right angle, which means all 3 sides are different lengths, all 3 angles are different. So it's a scalene triangle or an irregular triangle. This is the shape I was trying to draw earlier, an isosceles triangle. So you can see 2 sides the same length, 1 different. 2 angles the same, 1 different. So it's irregular, an irregular triangle or an isosceles triangle. And on the end we have 3 sides the same, 3 angles the same. That's an equilateral triangle or a regular triangle. So we've got here our 3 types of triangle. Not a right angled version of it, but we've got a scalene, an isosceles and an equilateral. Okay, here's the other shape I was trying to draw you earlier. They've all come up here. Can you see that these 4 sides are all the same length? But the angles opposite are equal, but they're not equal to each other. So this is called, well, it's an irregular quadrilateral, but it's also called a rhombus. And a rhombus, I always describe it as a bit of a wonky square because it's got all the sides the same length, but it's like somebody's tipped a square over. And this one is what I call a wonky rectangle. We've got 4 sides, so it's a quadrilateral. Opposite sides are equal. Opposite angles, are equal, just like on the rhombus. But we have 2 long sides, 2 short sides. So this one's a wonky rectangle, which is called a parallelogram. It's a lovely word to say, parallelogram. And it's an irregular quadrilateral. Here, 1, 2, 3, 4, 5, 6. It's a hexagon. But you can see not all the same length. Irregular hexagon. This one's a funny one. It looks like somebody's chopped the corner off. 1, 2, 3, 4, 5. It's an irregular pentagon. Somebody's chopped the corner off. Okay. 1, 2, 3, 4, 5, 6. So this is the regular version of this shape here. It's a regular hexagon. Here we have a shape called a kite. which is quite easy to remember because it looks like a kite, but it's also an irregular quadrilateral, but it's called a kite in that shape. And here's another triangle. This one is a right angle triangle. I think this one's a scalene one because this side is longer than this side, and this side is definitely longer. So it's a scalene triangle, which means it is irregular. And finally, this sign that looks like a plus, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's a dodecagon, and it is irregular. Okay, so some ones to pull out from here to remember. Regular pentagon, we've got a square. Scalene triangle, isosceles triangle, equilateral triangle. Rhombus, parallelogram, kite, right-angled scalene triangle. Those are some nice ones to remember for you. Okay, let's quickly have a look at some destination questions. Look at number 1. Why is this shape not a polygon? Have a second to think about it. It's closed. It's 2D. I can see 3 angles. 1, 2, 3. Or can I? Is this one joined at a straight line? Is this one joined at a straight line? No. So the only angle is actually this reflex angle here. This is not a straight side. Therefore, it is not a polygon because not all the sides are straight. Okay, the second one. Tanya says that this is a regular hexagon because all the angles are the same size. How do you know she cannot be right? Have a think about that one. Why is this not regular? Did you pick up on these 2 sides here? They're longer than the other 4. And all the sides have to be the same length. So it's not regular because not all the sides are the same length. Okay. Very, very quickly, I want to remind you how to draw lines of symmetry. And there's a bit of a pattern here because you're going to be doing an investigation today about lines of symmetry. And there's a bit of a pattern here. If the shape, we're just going to be looking at regular shapes for a minute. If the shape has an even number of sides, like this octagon, it's got 8, your lines of symmetry, again, I'm sorry I can't draw straight lines, will go from the middle of the side to the middle of the side, sort of like that. But you'll also be able to do corner to corner. So you must make sure, count the sides. If it's even, you'll be able to do side to side, corner to corner. Okay, so just look at that again. If you've got an even number of sides, I've got 8, you'll be able to do opposite side to opposite side, like these, the middles, and also opposite corner to opposite corner. And all of those will pass through the middle. Okay. So you can then count the lines of symmetry. And remember, you only count each line once. 1, 2, 3, 4. And then I can also, that's all the sides done, I can also go corner to corner. Make sure you don't miss any out. Go round in a system so you don't miss any out. And that's all of them. And then you would need to count the number of sides of symmetry. You only count each line once. So if you count this side, don't count this side. If you count this side, don't count this side. If the shape has an odd number of sides, like this pentagon, you have to go corner to opposite side, corner to opposite side, corner to opposite side, corner to opposite side. And again, don't miss any out. And then when you count them, you only count one side of each. So that is really important for what you're about to do. Here is the investigation that I want you to try and have a look at today. Regular polygons have the same number of lines of symmetry as sides. So what they're saying there is this shape here, this pentagon, has 5 sides, so that means it has 5 lines of symmetry. This regular octagon has 8 sides, so therefore has 8 lines of symmetry. That's what this investigation is asking you to prove. Is it correct? So your regular polygons are the ones where the sides are the same length. I'm not even going to attempt to draw it. The sides are the same length and the angles are the same. So you want to look at a square, a regular pentagon, a regular hexagon, a regular septagon, a regular, where have I got to, octagon, a regular nonagon, a regular decagon, and you can go as long as you want to. You can Google those shapes. If you can't remember what they're called, either look back in the video or Google regular 7-sided shape and it will come up, and have a go at working out the lines of symmetry. But the rule you must remember is even number of sides, you go from side to side and corner to corner. You have to do both and don't miss any out. If it's an odd number of sides, you go from side to corner. Don't miss any out. So what I want you to investigate is whether this statement is true. Okay? I would leave this page up while you have a go at that and see whether you think you've got it correct. Okay? Is that statement true? And I'll see you tomorrow. Bye-bye.